let's learn about some of the language that we use in polynomials in this video. So the first thing, the polynomial, the name comes from two words, poly and nomial. And poly is coming from a Greek word and that means many, and nomial is a Latin word that means names or terms. So polynomial then simply means a mathematical expression having many terms. And what is the general expression of a polynomial? The general expression of a polynomial is p of x equals a n x to the power n plus a n minus 1 x to the power n minus 1 plus many terms in between, and a1 x to the power 1 plus a0. So that's the general expression of a polynomial. And if you look at this one, this is one term and this is the next term and there are many terms in between, and then this is another term, this is another term. So this is of course a mathematical expression having many terms. And what are the different values allowed for n? N can be 0 or it could be any positive integer, 1, 2, 3, etc. So that means no negative indices are possible and also no fractions are allowed. Okay, and another thing, in minus 1, these coefficients of the variable x can be any real number with in not equal to 0. Let's look at some examples to see whether they are polynomials or not. Okay, so I have some function of x which is 2x square plus 5 plus 3x cube. Is that a function? Is that a polynomial or not? Look at the indices. 2 and 5 is x to the power 0, so that's when we write it as just a constant, and 3, so 2, 0, 3. So those are falling in this range. It's either positive or 0. So that's a polynomial. But again, this is not the best way to write a polynomial. We should write it in a descending order. So it should be the actual way to write this one is 3x cubed plus 2x squared plus 5. Even though nothing is wrong in writing this format, but even the mathematicians love to have some order. Okay. And another example I'm going to give you is 3x to the power minus 3 plus 2x squared plus 5. Is that a polynomial or not? Looking at this one, so this could be any real number. That's not a problem here. 3 to 5, fine. But minus 3, 2 and here x to the power 0, 0 and 2, that's fine. But minus 3 is something 3 divided by x cube. So we're dividing by a variable. Okay, or negative indices are there, which is not allowed in polynomials. So this is not a polynomial. Okay, so any negative indices which if it occurs, it's not a polynomial. And another example is p of x equals 3x to the power half plus 2. Is that a polynomial? Half is not allowed. It can only be 0, 1, 2, 3, etc. So half is not allowed, so this is not a polynomial either. Okay, now let's look at some of the language that we use in polynomials or different parts of the polynomial in here. The first thing is the degree of the polynomial. So the degree of the polynomial is the largest exponent in the polynomial. Okay, so in this one, n is the largest exponent. So this is a polynomial of degree n. So it's the largest exponent is the degree. And if the degree is 1, we call it as a linear polynomial. Okay, and if it's a degree 2, we call it as a quadratic polynomial. If the degree is 3, we call it as a cubic polynomial, and if the degree 4, we call it as a quartic polynomial. So for example, the equation of a line is a linear polynomial, so we usually write it as f of x equals mx plus b. So the highest power is 1. So it's a linear polynomial having degree 1. And quadratic polynomial, the equation of a parabola, so which is of the form f of x equals ax squared plus bx plus c. That's a quadratic polynomial. And cubic polynomial is the one which is having degree 3, and the example is f of x equals, maybe I can write down a specific example. If it's like 5x cubed plus 1, that's a cubic polynomial. Doesn't matter whether there's any term in between having 2, the power 2, 1, etc. It doesn't matter to have that. The only condition is the highest power, the coefficient of the highest power cannot be 0, and it should be 3 in this case. Okay, so that's when we say in one condition in here, an not equal to 0. So if the polynomial is of degree n, this an cannot be 0. Anything in between can be 0. It's not a big deal. Okay, and quartic polynomial, an example could be f of x equals 6x to the power 4 plus 5x plus 2. That's a quartic polynomial. It can have any term with the power 3 and 2, but it's not mandatory. But it should have a power 4 in it. Okay, and the coefficient, this coefficient cannot be 0. So the another part of the polynomial is the leading term. Leading term. The term with the highest index is known as the leading term. So if you have a polynomial, 5x cubed plus 2x squared plus 5, the highest index is 3, so this is the leading term, 5x cubed. And the coefficient of the leading term, so this 5, is known as the leading coefficient in here, leading coefficient. So the coefficient of the leading term. And something else as well, so which is the constant term. The constant term is the term having no variable, or sometimes we can call it as the term having a 0 index. When you call x to the power 0 is pretty much a0. So if in this term is the constant term. This is constant term because 5 can be written as 5x to the power 0. That's why we don't usually write it. And x has a power 0. Finally, there's some other language also that we often use in polynomials, and that one is monic polynomial. So monic polynomial is when the highest index term or the leading terms coefficient is 1. When an equals 1, we call it as a monic polynomial. For example, if the polynomial is of the form x to the power 5 plus 3x cubed plus 2x squared plus 5, this is a monic polynomial because this is the leading term, and leading term has a coefficient 1. That's why we don't write it. So this is a monic polynomial. It doesn't matter whether the other terms have coefficients, but this one, the leading term, shouldn't have any coefficient. And finally, there's a polynomial called 0 polynomial that's simply 0. So it's called the 0 polynomial. So pretty much we learn different language that we use in polynomials: the degree, leading term, leading coefficient, constant term, monic polynomial, etc. And what are polynomials and what are not. So having an understanding of these introductory terms, these language is really important as you learn the advanced topics in polynomials. Okay, we'll stop it here.